Today I will show you the execution of jagged array in Java using Visual Studio Code. So before going to the execution, I'll just explain some theoretical part, then we go for the execution. So we have types of arrays in Java. So that is one-dimensional array, two-dimensional array, and jagged array. So one-dimensional array, I have created one separate video. Two-dimensional, I have created one more separate video. So if you want to go for this, you can just refer to the previous videos of mine. Now in this particular class, I'll cover jagged arrays. Now what is jagged array? A jagged array in Java is a collection of arrays where each array may contain a varied number of elements. Now let's say suppose if I want the first row with 3 elements, second row with 2 elements, third row with 5 elements, fourth row with some 3 elements. Now here, if you can see every row, I'm trying to create different number of columns. First row I said 3, then 2, then 5, and again 3. So here we're trying to create the columns which are not fixed. So every row there is some different size of columns. So that is called as jagged array. But when you go for the two-dimensional array, which is fixed, suppose 3 by 3, 3 rows, 3 columns. So every row, 3 columns need to be there. That is mandatory. So a two-dimensional array, in contrast, requires all rows and columns to have the same length. But when you go for jagged array, we can create every row how many number of columns you want. You can decide. Now that flexibility is applicable for the jagged array so that the memory will not be wasted. When you go for the two-dimensional array, which is fixed size, and let's suppose you have taken 4 by 4, 4 rows and 4 columns, but you have used first row only 2 columns, second row you have used only 3 columns. So the other number of columns are wasted. So that is a problem in two-dimensional array, but that has been overcome with the jagged arrays. So every row, how many number of columns you want, that much you can define. Now jagged arrays are also known as ragged arrays or irregular arrays. Irregular means because we are not trying to put the fixed number of columns for every row. So every every row, there are different number of columns. Some could be same, some could be not same. So in that sense, they are calling irregular arrays. They can be created by specifying the size of each array in the declaration. For example, a jagged array with 3 rows can have the first row with 3 elements, the second with 2 elements, and the third with 4 elements. So there is no hard and fast rule like it is in two-dimensional array. Everything is fixed, but here we have the flexibility that every row we can create a different size of columns. Now, just look into this diagram. Here we have 3 rows. Now, if you take the first row where we start with a 0 index, then 1 index, then 2 index. So this row 0, row 1, and row are this 0, 1, and 2 are index numbers. Then column, this is the first column vertical, column 0 index, column 1 index, and column 2 index, and column 3 index. So every row, I'm creating a different array with a different size. So here if you can see, the first row has been designed with only 3 columns. Column 0 index, column 1 index, and column 2 index. Row 1, I have defined only 2 columns. Row 2, I have defined 4 columns. So this has been internally been framed as a separate array called array 1, 2, and 3. So when you go for two-dimensional, obviously it will be fixed like 4 by 4. So this will be 4, this will be 4, and this will be 4. But here the thing is, here I'm not using this memory. Here I'm not using this 2 column memory. So this particular thing is not wasted here. But when you go for two-dimensional, if you're not using this memory, that is wasted. So that limitation in two-dimensional array is been removed by this jagged arrays. Now how to declare and initialize jagged arrays? So if you can see the syntax, we have a data type like integer, float, character, double. Like that, we can put a data type here, followed by two subscripts. One is for the row and one is for the column. Space the array name. Assigned assignment operator with new. When you write new, memory is allocated dynamically at runtime, and the data type, whatever you have been framing the array for, whatever you write here should be written here. And here you can see the number of rows you need to specify. That is mandatory. How many number of rows you want. But here the columns, number of columns I'm not specifying here. I can specify later. Like row, suppose I write here 3. That means 3 rows I need to create. But here if you write something like 3, that means what? 3 rows, 3 columns for per row will be created. But in Jagged arrays, that is not the concept. But the rows obviously you need to frame. So I'm writing number of rows here, but I'm not going to write the number of columns per row because it's not fixed. So I leave that empty. Later on I can set. Now how to set? You can see here, if I take array name of 0, this is row number assigned with new data type. That means this data type, whatever you have been written here, the same data type with number of columns. That means the row number 0, how many number of columns you want. Next, row number 1, that is index number 1, row index number 1 need to hold how many columns. Okay, so like that, for every row you need to define. Now here, row n, number of rows minus 1. Suppose whatever you write here, 3, the index number will become 2 here. Again, assignment operator new data type of number of columns. So every row, see when you go for left hand side, this is the row number, row index number. For this row, how many number of columns you want, that you need to specify. The next row, how many number of columns. So every row we have a flexibility to define our own number of columns. Suppose you write here 3, so first row with 3 columns. Here you write 2, then second row with the 2 columns. Next you write the next row with 5, so 5 columns are going to design. Okay, now if you can just compare a 2-dimensional array and jagged arrays. Now if you take this rows with the same number of columns, so here 1 2 3 are rows are there, per row 3 columns are there. Now this is fixed, you can see it is fixed. But when you go for this, here also we write 3 rows, but the first row we have only 2 columns, second row we have 4 columns, third row we have 3 columns. So here the rows are fixed, but columns are not fixed. We can create our own number of columns. So every row with these columns have been acting as an array, internal array, or we call it as inner array. So this row we have 4 columns, that is one more inner array. This 3, one more inner array. So that's why here they have written inner arrays. These are all individual arrays. So rows with a different number of columns, but here rows with the same number of columns. So now that is the difference between these two. Now here the memory, whatever you want in row 1, like 2 columns, so you're defining only 2. Now these memory is not wasted. But suppose here you are using only 2 and you are not using this one, so this will be wasted because the memory's allocation is fixed. You use or not. But here, how much you want, only that much you allocate. So that is a priority given for the jagged arrays. Now coming to the advantages of jagged arrays. One is memory efficiency. Jagged arrays are more memory efficient than multi-dimensional arrays. Multi-dimensional implies the 2-dimensional arrays because they only allocate memory for the elements they need. Now that is the specialty of the jagged arrays. How much memory you want for row 1, row 2, row 3, you need to specify individually. In a multi-dimensional array with the fixed size, all the memory is allocated even if some elements are unused. So the 2-dimensional array, in the previous slide I was just comparing. Like if you use the number of columns, it's fine. But suppose if you're not using all the columns, then the memory is wasted there. Then coming to the next advantage, flexibility. Jagged arrays are more flexible than multi-dimensional arrays because they can have different sizes for each row. Jagged arrays enable the representation of non-rectangular or irregular data structures. So in the previous slide, you have seen that when you go for two-dimensional array, it is the rectangle or the number of columns has been fixed for every row. But when you go for the jagged arrays, it's not fixed. So first row, you have two columns. Second row, something 5 or something. So that is called as irregular number of columns we do have. So in that sense, they are saying irregular data structure. Now, easy to initialize. Now, jagged arrays are easy to initialize because you can specify the size of each row individually. So in the syntax, we have seen clearly that row index number 0 is holding so many number of columns. Row index number 1 will be holding different number of columns. So that flexibility is there, and it's very easy to initialize each and every row. The suitability of jagged arrays lies in their ability to store data that varies in size or is generated dynamically. So every row we can vary the number of columns. Now that flexibility is there. The next advantage is enhanced performance. Jagged arrays can provide enhanced performance in certain scenarios, such as when you need to perform operations on each row independently, or when you need to add or remove rows dynamically. Now, in these situations, I can suppose if you want to work some operations on an individual row, then obviously you can do that manipulation on the individual row independently, or you want to add or remove some sort of rows, that also can be done very easily. Now, more natural representation of data. In some cases, jagged arrays may be a more natural representation of data than rectangular arrays. Rectangular arrays implies two-dimensional arrays. Now, for example, when working with irregularly shaped data, now when you go for these geographic maps, the data is not fixed. Okay, the data has been changing dynamically. So that can be considered as irregularly shaped data. A jagged array can be more intuitive way to represent the data. Okay, so like this situation, so we go for the jagged arrays. Now it is easier to manipulate. Jagged arrays can be easier to manipulate than rectangular arrays because they follow far more direct access to individual elements. With rectangular arrays, you may need to use more complex indexing or slicing operations to access subsets of the data. So when you go for jagged arrays, it's much more simpler to extract the values or access the values from an independent row, rather than going for the two-dimensional array, which is a little bit complex for accessing the values. Now, what are the common use cases or applications where we use this jagged arrays? Now, common use case for jagged arrays include, in case of image processing, game development, 3D graphics, data analysis, and working with mathematical models, etc., we use these jagged arrays. Now, additionally, they are often used to store web page layout information or in applications where users customize the interface or content displayed. So, content-oriented applications can also be using these jagged arrays. Now, jagged arrays are also used in applications that require a large amount of data to be stored in compact format. So, compact format in sense, the memory should not be wasted. So, obviously, how much data you want to store, that much only memory we need to take. So, these are few theoretical concepts of the jagged array. Now, I will show the demonstration of how to execute or how to write the program in VS Code. So you need to have Visual Studio software in your system. So once you install, you can just type and just search and click that Visual Studio Code environment. Now this is the Visual Studio Code environment. Now whichever is not applicable, you can close. Now here, whenever you're creating Java files, you need to save the Java files into the respective folder. So in my previous videos, I've clearly mentioned how to create a Java folder and how to save the files. Just you can refer to my previous video for that. Now here I have created one folder called Java VS4. Okay, in a main folder called Java VS1. So whenever you want to create a new file, you have an option here, new file. Just click that and give the name of the file. And you know that whenever Java application is saved, you need to put a .java extension for the application. So here I have a few applications. I just explained that. Now this is the first application. Now the class name is Jagged Array Demo 1. And any application in Java should start with the class keyword, because it could be instance variables or methods we are going to write into the class only. So we have a class keyword followed by the class name. And class name also, when you're clubbing more than one word, you try to keep the first letter as capital. That is the notation in Java. And next we have a main method, public static void main. I have clearly mentioned the description about what is public static void main in my previous videos. You can just go through that. Now, coming to the array declaration of the jagged arrays. Now here I'm trying to create an integer array, and ARR is the name of the array with two subscripts. One is for the row and one is for the column. Assignment operator, new, and you need to write the same data type. Whatever you're writing here, the same data type with number of rows specified clearly. So three rows. Three rows means row 0, row 1, and row 2. Because the index number starts from 0. So I'm saying row 0, row 1, and row 2. But every row or each row, how many number of columns, I don't know. That's the reason I'm not specifying. Okay, then later on you can specify that. How to specify? Now, ARR of 0. So you can see only one subscript here. Now the 0 implies the row number, row index number. So row index number 0 should hold how many columns? The right hand side you need to specify one subscript. Now this subscript is for the column. So left hand side is for the row, right hand side is for the column. Now here I'm trying to directly go for initializing the values like 1, 2, 3. That means 3 columns. That means row 0 with 3 columns, row 1 with 2 columns like 4 and 5 we are specifying. Then row with 2 index number is holding 5 values. So first row 3, second row 2, and third row 5. Now this is the concept of the jagged arrays. So 3 rows, so row 0, row 1, and row 2. Every row there is a different size of the value. Directly we are trying to assign the values. So every value is nothing but one column. I want to print that. So I'm writing system.out.println two-dimensional jagged array will print as it is because I put in double quotes. Now in order to print that, I need to take a nested loop, because when you go for two-dimensional, the outer loop is for the row, the inner loop is for the column. So here we are taking int I equal to 0, I less than AR dot length. So AR dot length is nothing but the 3 rows what you are specifying, right? This one. 3 outer is nothing but a number of rows, so here you get 3 array length, then I plus plus. So 0 is less than 3, the condition is true, you enter into the block. Now one more loop, j equal to 0, j less than ARR of 0 dot length. ARR of 0 means row 0. Row 0 is holding how many values? 3 values. So here the length will be 3, and it is going to print that. So 0 less than 3, so it is going to print ARR of I is 0, j is 0. So you're going to get the answer as 1. This one. Again, j plus plus. J is becoming 1. Still I remains 0 only. Because inner loop condition need to fail. Then only the outer loop will get incremented. So I is still 0. J is becoming 1. So 0, 1. That means 0 row, first column. That is 2 value. This one is going to print. Again, j is becoming 2. 2 less than 3. Then here a of array of 0 comma 2, then you are going to print like this. Now again j becomes 3. 3 less than 3, the condition is failed. Then this line get executed, that is the next line. Then I gets incremented, I becomes 1, because it was 0, no, it becomes 1. That means row 1 we have entered now. 1 less than 3, the condition is true. Again you go to the inner loop, and again j starts from 0. That means I value is 1, j value is 0. So 1, 0 means first row, 0 column. Means you are going to get this. Then j is get incremented. Again the condition will become true here. 1 less than 2. Because now here you can see ARR of I value is 1, right? So what is the length of this? Only 2 values. So here the length of j is less than 2. So j 0 and 1 only will work. So here these 2 values printed. Similarly, for the third row, we are going for the 5 iterations internally. So let's say I'll just save the program and run. You have a run button here. Just click run code. And here you can see the two-dimensional jagged array is print as it is because I have put in system.println. Now the first row 1, 2, 3, second row 4, 5, third row 6, 7, 8, 9, 10. So only these values will be allocated some memory. Okay. So here there is no memory wastage concept because we have defined clearly each row how many number of columns you are going to have. Now this is one application. Then I'll go for the second application. Now here the class name I've changed to jagged array demo 2. Then the main method. Now here if you see this line, the number of rows is 4, that is fixed, but number of columns I need not write here, but here I'm going to write. So ARR of 0 means row 0, 1 column. Then row number 1, that is the index number 1, you need to have 2 columns. You're clearly specifying here. Your earlier program is specified values, so we are not writing number of columns. But here I'm not writing any values directly, so that's why I'm writing number of columns. So these numbers are number of columns. These numbers are row index numbers. So if I take a row with 2 index number, need to hold 3 values. If I take a row with 3 index number, I need to have 4 values. So first row you have 1 value, second row 2 values, third row 3 values, fourth row 4 values. Now I taken value equal to 1 into value equal to 1 by default. Then again the same sort of loop we are writing, the outer loop and inner loop. Okay, so the condition is also been implying the same. Okay, because when I talk about ARR length, you get this 4 as an answer here. Okay, row, because the outer loop is for row, right? So 0 less than 4 condition is true and you enter into the block. J is starting with 0, j less than ARR of I value is what? 0, no? 0 dot length. So here if you take 0, we have only 1 column, so the length of the particular row will be 1. So 0 less than 1, the condition is true. Then ARR of 0, I value is 0, j value is 0, should be initialized with value called 1. Then you are making value plus plus incrementation. And after this j is in value means value is 1 initially, it become 2 and j is incremented to 1. 1 less than 1, the condition is failed. Then the I get incremented, I becomes 1. 1 less than 4, the condition is true. Again you get into this. Now here when you go for 1, the second, this row we are talking about. So how many number of columns? 2 columns are there. So the length will be 2 here. J is 0, 0 less than 2, the condition is true. And here the value which is already updated to from 1 to 2, the 2 need to store where? I is 1, j is 0. Okay, in that location I need to store 2 value. Then similarly, I need to go for j incrementation. J becomes 1, 1 less than 2. Again I need to store ARR of 0 and 2. 0 and 1. I need to store the value called 3 because the value every time the value has been getting incremented. So if you can see the output, you can understand. Now this is for assigning the values. Now this is for printing the values. The code is same. Outer loop, inner loop, the condition is same. Here we are trying to print. But here what we are trying to only assign the values. Storing the value, here we are printing the value. Okay. So just save this and execute. Now here you can see the output. Now first row only 1 value. Second row the value was incremented, no, 2 and 3. Then third row 4, 5, 6. Fourth row 7, 8, 9, 10. Okay, so 1 column, 2 column, 3 column, 4 column. Similarly we have defined here first row 1 column, second row 2 column, third row 3 column, fourth row with the 4 columns. But the index, this left hand side are the index numbers, because the index number start from 0, we are starting with 0, 1, 2, 3, 1, 2, 3 because 4 rows. But here these are not index numbers, these are the number of columns per row, that you need to have a clarity. Now one more application I'll show. Now the name of the class I've given like Jagged array demo 3. Now here I'm creating one jagged array with number of rows is 2. Number of rows is 2, and the number of columns anyhow I am not going to specify. So if you go for the first row, that is index number 0, I'm having 4 columns. Then index number, that's the next row, I'm having number of columns is 5. Okay, so row 0, 4 columns, row 1, 5 columns. Now here I'm taking a count of 0. Then here also the outer loop and inner loop. The outer loop is for the row, inner loop for the column. Now here also the logic is same, where I'm trying to give the count value. So it is initially 0. Okay, so count plus plus means the post incrementation. So the count is again starting from 0. So I is 0, j is 0. So first row 0 location you're going to store 0. Okay, when you talk about array of I dot length, so you can see this number of columns is 4, right? First row, so you get here 4. But totally how many number of rows are there? Only 2. So the row number here, the length is only 2. Here for first row 4, the second row is 5. Okay, this is already we have defined, right? So here also we are trying to assign the value. Now whenever the j is becoming 1 less than 4, the condition is true. The count was initially 0, it become 1 now. So a of 0 with 1. Okay, index we are going to store 1, then 2, 3, 4 like that. So here we are assigning the values, we are trying to print the values similar to the previous program. But here I'm taking only 2 rows. Okay, so file, save, and just run the program so that you can see the output. So there is some error, just check. Save and run. Now I can see the output. The first row with the 4 columns, the second row with the 5 columns. So in this way, we are trying to print the value. Every time the count value which has started from the 0 is getting incremented. Okay. So this is for assigning the values into this location, and the same thing I'm trying to print here. Okay. So in this way, you can work with the jagged arrays. So wherever the memory optimum utilization is required, you can go for the jagged arrays. So I hope some input are given on to the jagged arrays. So if you like this video, please share and subscribe. Thank you.